Okay, guys, in 9:15, we're talking about the ways that we could prove a parallelogram. Actually, only 4 out of these 6 ways are going to work on a coordinate plane, but they all stem from the properties of a parallelogram, which was something that we discussed in Unit 5. But the first way that we could prove a parallelogram would be to prove that both pairs of opposite sides are parallel. So in order to do this one, you guys would want to find the slopes of all 4 sides. And obviously, if you have opposite sides, if both pairs of opposite sides have the same slope, then that would mean that both pairs of opposite sides are parallel, which would show that you have a parallelogram. Second way that we could prove a parallelogram is to prove that one pair of opposite sides are parallel and congruent. So you're going to find the length / distance and slope for only one pair of opposite sides. Third way, prove both pairs of opposite sides are congruent. So we'd want to find the length / distance for all 4 sides. Again, if both pairs of opposite sides are congruent, then you're going to have a parallelogram. 5 and 6 are ones that we cannot do on a graph. The only thing that we can determine on a graph regarding angles is whether or not we have right angles. And we know that we'll have right angles if we have sides that have slopes that are opposite reciprocals of each other. But there's really no good way for us to do 4 or 5 on the graph, showing that both pairs of opposite angles are congruent. We'll say can't do on graph unless they were just right angles, but in a parallelogram we don't even have right angles. Prove one angle is supplementary to both of its consecutive angles. Again, can't do on graph because there's no way for us to determine those angle measures. And then lastly, 6 says prove the diagonals bisect each other. To do this, all you guys have to do is find the midpoint of both diagonals. If those midpoints are the same, then those diagonals bisect each other. So in a second, we're going to do the 4 examples that we can down below on our note sheet. Before we start to find the slopes and the lengths of some sides, let's go ahead and graph what we think might be a parallelogram down here. We'll plot A at 2, 2. B is at -4, -2. So that's A. This one is B. C is at -2, -7. And then D is at 4, -1, 2, 3. So we're going to use those methods up top to show that this is indeed a parallelogram. First one we'll do in the top left would be we're going to prove that both pairs of opposite sides are parallel by finding the slopes of all 4 sides. So this is going to be for the first method on our paper. First, we can find the slope of AB, and because we have it graphed, we can just go ahead and count what that slope is. If you don't have graph paper or graph handy, you guys can use the slope formula, which is y2 minus y1 over x2 minus x1. But because I have it graphed, I'm just going to go ahead and count. So AB is going to be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So AB has a slope of 4 over 6, which simplifies to 2 over 3. Next side, and I want to make sure, so AB is opposite side CD, so I'm going to go ahead and find the slope of CD. Again, I'm going to start down here, and I'm going to just count up to get to point D here. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So for CD, we also have a slope of 4 over 6, which is equal to 2 over 3. So we've shown that we have one pair of opposite sides, and then I'm going to do the exact same thing. I'm going to count the slopes for BC and AD. So the slopes of BC and AD were both, you went up 5 and back 2, which would be a slope of negative 5 over 2. It does not matter if you guys put that negative sign in the front of the fraction, on the top of the fraction, the bottom of the fraction. It just indicates a negative slope. So because both pairs of opposite sides are parallel, we know for sure that this is a parallelogram. Okay, method number 2 was to find the length and distance, find the length slash distance and slope for one pair of opposite sides. Well, we've already found the slopes of all 4 of our sides, so I'm just going to pick one pair of opposite sides. I'll use side AB and CD. We know that AB has a slope of 2 over 3, and CD also has a slope of 2 over 3. So we've got definitely one pair of opposite sides that are parallel. Now we're just going to see if those pairs of opposite sides are also congruent to each other. So we could do it one of 2 ways. We could use the Pythagorean theorem in helping us find the length of AB and CD. So if we do that, if we're looking for the length of AB, you can create a right triangle. Use the dimensions of that right triangle. So you're going to have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So to find the length of AB, we're going to do 4 squared plus 6 squared is equal to c squared. Again, it's easy to kind of use this method when you guys have a graph. If you do not have a graph, then you could use the points A and B and plug those into the distance formula, which is what we practiced on, I believe it was Friday's lesson in proving right triangles. So you could always use the distance formula or the Pythagorean theorem in helping you guys find length. And what we end up with over here would be 52 is equal to c squared. When we want to get c by itself, we square root. So the length is the square root of 52. If we wanted to simplify, we could, but really all that we want to see is if side CD also has this same length. So it really doesn't matter if you guys simplify your radicals or not. If we asked for what the length was, we would likely ask you guys for it in simplest radical form. But if we're just doing it, if we're just trying to compare some stuff, then you guys can leave it unsimplified. So I'm going to go ahead and do the same thing that I did for AB for CD. All right, and CD, when we made a right triangle out of CD, it ended up having the same dimensions, so those have the same length. So box number 2 shows that we have one pair of opposite sides that are parallel and also congruent to each other. Okay, the third way is just showing that you have 2 pairs of opposite sides that are congruent. We have already found the lengths of sides AB and CD in method number 2, so I've gone ahead and written down what those lengths are. If we wanted it for CB and AD, we're going to do the same thing. You guys can make your right triangles, or again, you can use the distance formula instead. So you're using 2 and 1, 2, 3, 4, 5, I believe. Yep, 2 and 5. Got to go all the way up to the point. So to find BC, we're doing 2 squared plus 5 squared is equal to c squared, and then we'll see and make sure, or we'll just kind of check to see if this triangle has the same dimensions, which I know it's going to. Again, 2 and 1, 2, 3, 4, 5. So AD would also be 2 squared plus 5 squared equals c squared. So when we finish those up, you're going to have 29 is equal to c squared. If we were to square root that, c is equal to the square root of 29. Over here, you also have the square root of 29 equals c squared, so c is equal to the square root of 29. You have 2 pairs of opposite sides that are congruent to each other. All right, guys, so what I've already kind of written down is I've drawn in the diagonals of the parallelogram. Diagonal 1 would be located at AC, the other one is from B to D. So over here was where I went ahead and wrote down those coordinates for A, C, and then again for B and D. So all we're doing in the last way is showing that the diagonals bisect each other, and we're going to use the midpoint formula for each of these segments. We're going to check to see if they both have the same midpoint. If they do, then those diagonals bisect each other. So if I'm looking for the midpoint of AC, I'm going to use my points up here to plug in down here. So I'm going to add my x's. So it would be 2 plus negative 2 divided by 2. And then add your y's, which would be 2 plus negative 7 divided by 2 is going to give you guys a point. 2 plus negative 2 is 0. 0 divided by 2 is 0. 2 plus negative 7 is negative 5. Negative 5 divided by 2. You guys can leave it as a fraction, or if you'd like to convert it into a decimal, that's fine. So I just plugged in, I used my points A and C in the midpoint formula. I'm about to do the same thing for B and D and hope that it has the same midpoint here. And diagonal BD also ended up having a midpoint of 0, comma negative 5 over 2. So the two diagonals do bisect each other because they have the same midpoint. All right, so flipping over on the back, we're talking about how we could prove that a quadrilateral is a rectangle. There are 3 different ways that we could do this one. First way, you could prove that it's a parallelogram. So you would use any of the 4 methods that we talked about on the front of this notes page. And then after you prove that it's a parallelogram, you would prove that the parallelogram contains at least one right angle. So what we're looking for is we're looking to see if slopes are opposite reciprocals. Second way, again, prove that it's a parallelogram using any of the 4 methods on the front of this notes page. Then that the diagonals of a parallelogram are congruent. You could use the distance formula or Pythagorean theorem on a graph to show that the diagonals are congruent. Lastly, you could prove that all 4 angles are right angles, and again, you're just looking to see if I guess in this one, you would just show that the consecutive sides are perpendicular. So if those sides that are right next to each other are perpendicular, that would mean that you guys have right angles. Again, if we're checking to see if something's perpendicular, then we're checking to see if the slopes are opposite reciprocals. So I've gone ahead and graphed the quadrilateral on our graph here, and now we're just going to kind of do some work to show or to prove that it is a rectangle. So the first way that we're going to do is we're going to look back at method 1. We have to first prove that it's a parallelogram. I'm going to show that the opposite sides are parallel in proving that it's a parallelogram, because then if I kind of find the slopes of the sides, I can then look to see if we have slopes that might be opposite reciprocals of each other, which would then indicate right angles and prove that the parallelogram is actually a rectangle. So I'm going to go ahead and do that now. So it's pretty easy finding the slopes of all of our sides here, because if you guys remember, horizontal lines are going to have a slope of 0. So my sides AB and DC have a slope of 0. And then our vertical sides have a slope that's undefined. So these would be the slopes of the opposite sides. So because these two are the same, you have 2 pairs of opposite sides that are parallel, which shows that you have a parallelogram. And then where we'll take it from there is, do we have at least one right angle? Yes, this also shows us that we're going to have 4 right angles, but we do have at least one right angle because a slope of 0 and a slope of undefined are opposite reciprocals of each other. So, yes, slopes are opposite reciprocals, which indicates that we have a right angle. And we could actually use this method would work for like method number 1, but it also shows that we have all 4 angles are right angles. So this would kind of be your work for method number 1 and 3. Okay, so with method number 2, we have to prove that it's a parallelogram. Again, I'm just using looking at the slopes of both pairs of opposite sides. Because the slopes of both pairs of opposite sides are the same, then we know that it's a parallelogram because both of those pairs of opposite sides are parallel. You could use the distance formula for all the 4 sides if you wanted to. Again, you could use whatever you guys wanted to from the front to prove that it's a parallelogram. And then the second step is going to be that we show that the diagonals of the parallelogram are congruent. So are diagonals congruent? So we'll go ahead and I'm going to go ahead and draw those in there, and then I'm also going to write down what the distance formula is, because you guys can plug in those points into the distance formula to find the lengths of the diagonals. Okay, so here's our distance formula. Here are our points for diagonal AC. I'm going to go ahead and plug those in to find the length of AC. So we're going to have 4 minus -2 squared, and then -1 minus 3 squared, which is going to come out to be, again, make sure we add that. So you have 4 plus 2 is 6 squared, so that's going to be 36 plus what? 16 is going to be the square root of 52. You do not have to simplify if you don't want to, because again, we just want to see if these are going to have the same length. So because it's a parallelogram and the diagonals are congruent, this shows that it's a rectangle.